Hey, welcome to Doozer Shop. We're out here at the Colchester lathe, and my last video I was very excited. I had the lathe, put a lot of stuff on the lathe, got it back together. Still working through a few problems, and I talked a little bit about this lathe, you know, in the British design. Good and bad, it's just different. I think they had some real issues with the power feed mechanism, as I've been showing you guys right along. If you remember a long time ago, I said I think some of the reason that the bushings wore out, well, originally I didn't even have these bushings. And somebody before me, a smart and talented person, bored out the apron and the rocker box for bushings, and they were worn completely out when I got the lathe, and I thought it was the spring for the detent plunger that was so strong that was causing them to wear out. Well, I think I'm revising that theory, and I think I know the real reason that those bushings wear out so quickly, and it's really an Achilles heel in the design. And I know a lot of you guys might be saying, well, Doozer, you know, they sold thousands of these lathes. Are you the only one with this problem? No, I don't believe so. I corresponded some time ago with Keith Fenner, who has the same lathe, and he replaced he bored his apron and rocker box for bushings, and he, instead of using aluminum bronze like I did, he used like hardened steel or 4140 steel, or I forget exactly what he said, but he said hardened steel bushings, which is excellent fix. But that cures the symptom a good bit, but I don't think it addresses the engineering flaw, and it is a flaw. So let me kind of show you handheld what I'm seeing, okay? Well, first of all, let me angle you down. All right. So you can see, you know, here's that rocker, and it goes side to side, and the action is fabulous. Drops out. Get it lined up. It's fabulous. And come over to here, and this should be spinning, by the way. You got to kind of make sure. Okay, yeah. But if the gears are meshed, boom, it goes in. I was kind of afraid to throw it in as hard as I am now. I was kind of easing it in, but goes in super smooth. I mean, that's like glass. In, bam, nice and tight into the pocket, and just, you know, push down on it, and it comes right out because it's compressing that detent spring. Very satisfying. Very satisfying. I wish you guys could experience how cool this is. This is a very cool mechanism. Come back over here. And the first one, I don't slam it too hard because I don't know if the gears are meshed. Okay, and it goes in, so I'm good to slam it home. So that's the power cross feed. So let me go handheld and let me show you. There's a binding situation going on, and it'll be real evident. Maybe I'll have to draw this on the marker board. Let me grab the camera. And so you guys know, I've been using a Starrett magnetic base to mount the camera. Okay. Got my oiler, I don't think I tightened them, my oil cups on. I use the elbows and the straight down cups because the angle cups, I didn't like the way they were fitting. And over here, of course, I got the oil cup for the half nuts. But that's not what I came here to show you. Alright, let me kind of take the wrist strap off the camera. I get my lamp shining in there. Alright. Alright. So, alright. Forgive, I screwed, alright, forgive this fitting and forgive that fitting, ignore that. I gotta get you. Okay, that's what I wanted to show you. So, I'm gonna rock the, no, you can't see it there. Let me go over to the other one. Okay. Alright, now, that's the cross feed engaged. Alright, that actually, I gotta angle it different for you to catch the action. I don't know if you can see that bushing. There's a film oil, so there's a washer on there. Let me pull it. So there's my spacer washer, okay? Not that it matters, but we'll get that out of the picture. Let me shine it. Alright, now that you can see the bushing on the power feed shaft. Okay. I'm turning the cross feed, which is engaged. So look at the handle. See, the handle's kind of bobbing around a little, which is not necessarily bad. Let me get you really straight on shot if I can. Alright, so I'm going to move the handle again. See how the bushing is sliding along the shaft? It's moving about 25-30 thousandths. See how that's moving? So what that's doing, well, what that's doing, and the reason it's doing it, is this, okay? So let me pop this out of gear. Try not to hurt the camera. Okay. There's the worm gear. So to the left of the worm gear is the spur gear that takes power off the feed shaft. Okay? So the worm gear is what meshes with the, now it's a steel worm. That worm gear meshes with, you can kind of see up in the slot there at the very top of the screen. It meshes with the cast iron gears in the apron for feeding cross or feeding along the bed. But anytime you have a worm gear, you're going to have thrust side to side. You know, well, yeah, you can see it. So spur gears do not generate side thrust, but worm gears generate a ton of side thrust. Part of the reason that they're not very efficient and they eat power and turn power into heat. They turn horsepower into heat. Yeah, that's it. But the side thrust So when that bronze detent, okay, that's the, this is the lever handle, this is the lever handle, and that's the detent plunger. And this one I made out of bronze. And you can see when it goes into the slot, it engages, there's a counter bore just back beyond the slot for that detent plunger to click into. So all the sideways movement, well, first of all the up and down move. Okay, so when you swing the rocker up into position, it keeps it locked in the up position. But that's not all that detent plunger does. It not only allows the handle to click into position and the rocker box to come up, which allows the worm gear to mesh with the worm wheels. That bronze plunger, see, it's the bronze plunger is in the counter bore. That not only keeps the handle up and the rocker box up and the gears in mesh, it absorbs side thrust, fore and aft thrust, depending on the feed direction. It could be thrusting this way or thrusting that way, of the rocker box. So the rocker box houses the worm gear, and like I said, that detent plunger serves two functions: not only to keep the rocker box up and engaged in position, but it also absorbs the side thrust. And what you're doing is you're absorbing the side thrust or the side torque. Well, it's thrust. It's not twisting torque. It's physical thrust, pushing and pulling. You're absorbing the thrust of that whole rocker box assembly. So in other words, to say it, that rocker box assembly wants to twist. And it wants to twist about the axis of the rocker box centered between the bushings, okay? Now what that means is, so there's a bushing on this side that I'm showing you now, and there's a bushing on the other side, and you've seen how that rocker box wants to kind of twist fore and aft. So that shaft that I'm pointing to with my finger with the shadow, that shaft is where the worm is. And I know, well, actually, could I shine the light? Maybe I can shine the light better. I don't know. So there's a good side view of the rocker box engaged in position. Oh, and there's, at the very top of the screen, you can see one of the worm wheels, one of the gears that, connected to the power feed of the apron. So, looking at the side of the rocker box, as I showed you initially, this box wants to come basically towards us and away from us in this camera shot. Like I said, it's secured in the apron wall, but its origin of motion is kind of hinged where these bushings are on the feed shaft. So I'll show you again. If you look at that bushing and watch the shaft, you can see the keyway in the bottom maybe. So it's moving fore and aft. See it moving? So what I think would be the most appropriate thing to do here, let me kind of, some oil drips. Oil drips are good. Kinda. Alright, there's a shot. I can't zoom out anymore, but here, let me unscrew this. So those are 1/8 inch pipe thread ports, and we're looking directly under the rocker shaft, and it's currently engaged. So I didn't use those two 1/8 inch pipe thread ports. Those are for the bushings on the long feed rod, but I figured it's just easy to, you know, use an oil can and oil the feed shaft there, the feed rod. So now you can see that elbow there, and I got an elbow threaded in there, and I got one threaded in there. That I am going to do oil feed with hoses, because that's the let me show you again. That's the worm shaft, okay? So that's why, where those elbows are just loose in there, I'm going to feed oil to those bushings. Actually, it's the shaft running in the cast iron. And you can see up there the gears in the apron, which get powered by the worm. So I said all that to say this. So let me go turn the camera again. So those two rear 1/8 inch pipe thread lubrication holes, like I said, are for those bushings that the long feed rod runs in. But like I said, it's so easy just to put oil on the feed rod. You can lay it in the keyway. I didn't even drill holes in the bushings. So those are kind of not being used. But what I need to do is I want to put a little tab, a little tang, I guess a tab on the bottom. I want to put a tab on the bottom of this rocker box, so when it's engaged in feed mode, it's not only there's where the plunger resides. Alright, there's the plunger. There's the handle, the chrome handle, and then there's the plunger. There's the drip of oil. So that's the detent plunger. I know it looks real big because I'm super close to the camera. That's a detent plunger holding it in the apron in the front, but there's nothing in the back here. So if I put a tab hanging down the back of this rocker box that engages in a slot that holds it from moving fore and aft, what's happening is the worm gear is moving off axis a little bit, and it's binding, it's pinching. And I think I got the gear mesh between the worm and the worm wheels really, I guess, a little tight, maybe not. I tried to give like about 10 to 15 thousandths of radial mesh clearance, and I know that's not how you measure it, but that's kind of the best way I can describe it. So let me pull the camera back here. So basically, it's going to lock in. It's going to lock in with the bronze detent plunger there. That's going to have a tab that comes down. So what I was doing is I'm going to screw this in and pretend this 1/8 inch pipe nipple is a tab made out of steel on a bracket. So come down, move the lamp. So that would be engaged, and there'd be a slot in a bracket mounted flat under the apron, okay? So straight down picture that as like a hardened steel pin or an Allen bolt or something, the head of an Allen bolt, engaging in a slot. And then when you drop out the rocker box, it slides away. So, use a popsicle stick, tongue depressor. Okay. So think of the tongue depressor stick here being a piece of bar stock with a notch milled in it, and you know, when you engage the lever, it has a slot in it and locks it in. It would lock it in fore and aft, you know, the sideways it would lock it in. All right, so picture that piece of wood has a slot in it, and it's locked in. The pipe nipple is a tab, and it's locked in like a V slot or U slot, whatever. And so that's engaged, and that be holding it, and disengage it and drop it down. Yeah, I know it hits the elbow, but we're gonna change that. But it's just an idea. Obviously, this wood is too thick. Okay, I think it's an inch thick. So that would be engaged, and it would be locked in a slot, and boom, it's unlocked. Locked in, it restrains the fore and aft thrust of the worm gear, and when you disengage it, it swings clear, and you can, you know, move your rocker box. Whoa, that looks cool. So that's the plan. Good Lord. There's a lot of explaining, but that's about the best way I can show you guys. Man, it goes in so beautifully. You just, once it gets over that little Humpty-Loo, there's a little ramp, and then it just locks in just as pretty as can be. And then, I mean, that's just working really nice. But, like I said, that's causing binding. What I mean when I say, let me give up. What I mean is, if you spin this, it gets tight and it moves a little bit. If you go the other way, it's actually moving pretty good. Okay? It moves really not too bad. But if you go this direction, it's actually working pretty well because there's no torque on, there's no resistance. This turns easy, but if you go to the apron feed, if I do it again, all right, let me spin it. Oh my God, that's tight. If I go this way, yeah, it's tight again. It's actually, this binds up a lot. If I go this way, if I power through it, it's actually moving. I'm actually moving it ever so slowly. But if I change direction and go this way, it binds up pretty hard. And there's a reason for that, because it's supported in one direction. Let me flip the lamp, the portable lamp around. Kind of. All right. So if I drop down, there's that bushing and that spacer washer, right? And all right. So I'm coming in, and I'm locking it in. I hope you can see that. So what's going on here is there's that bushing and then that spacer washer. So in this position,
the thrust generated by the worm wheel, okay, is pushing through the bushing, and that's the reason I got that spacer, and it's hitting the the wing of the apron, okay? There's the apron, the side of the apron. So what's going on is when the rocker box wants to come, this way, it's supported, okay? But when it wants to go that way, it binds, okay? So it binds up going that way. So thrusting against this side of the apron, right, is feeding towards the chuck. Basically, the reaction force, the rocker box is pushing this on the apron wall, and the supporting structure of the apron wall is providing a solid foundation to prevent this rocker box from deflecting. That's why feeding towards the chuck in that direction is fine, but coming this way, feeding in this direction, the rocker box wants to go the opposite way, and that's when it binds. So let me flip the lamp around this way. So if you come, so there's a big piece of hunk of nylon, right? See it? That's a nylon. Let me touch it. It's a big spinny piece of nylon. That's touching the apron wall. Let me so that nylon is cut to length to support the. Let me flip the lamp around again and move the oil can, because oil's our friend. Spill the Loctite. All right. So, like I said, in this direction, for the feed, boom, you got it. It's not going to engage. Hold on, let me twist it a little. Maybe. No, let me twist it. No, let me twist it. There, now it's in. So, when the cross feed goes one direction, it's pushing against that wall of the apron, right? See the oil drip? So the rocker box is supported, and I think this is feeding towards the center from the outside in. No, this in this direction is supported facing from the center of the chuck outward. I don't know, I like to face inward, but anyways, so the problem is not this side, but it's in the middle. When you're feeding, yeah, I know my light is horrible. Hey, scooch over on the. All right. Yeah, the problem, it switches, right? So this end is unsupported in feeding in this direction, and then back if you're and then this end is unsupported with the bed feed. If you're going away from the chuck towards the tailstock, then this is unsupported, right? So that's the problem. Like I said, so to fix it, I'm going to, like I say, this 1/8 inch pipe thread, this is sort of simulating the tab I'm going to put on there. So what I'm going to do is I'm going to put a piece of steel between here, like a piece of maybe 3/8 plate or 1/2 inch plate or something, maybe 1 inch wide. And I'm going to put a tab sticking down, maybe a square tab or maybe an Allen headed bolt, so it's hard, coming straight down. And because I'm not using these holes, these 1/8 inch pipe thread holes for lubrication, I think what I can do is I can tap them for 7/16 20, I think is fine thread, and then use a flathead countersunk screw in to attach a piece of steel, a narrow strip of steel plate from one side to the other, and then in the center have the tab go down, and then I want to have a piece of steel going across the bottom of the apron. It's actually going to tie the apron walls together. And what the deal is with that, let me back up so you get a full idea of what I'm talking about here. So there were some 1, 2, 3 holes in the apron, and I think that was for a power clutching lead screw nut, and I don't know if I talked about that, but I tapped that hole and that hole, and those are like some equal distance apart. They're like 1.5 inches apart, and there's some exact specified from the distance from the center of that bushing. Because I remember in my last video, in one of my previous videos, I laid this out on the SIP jig bore. So they're on center with the shaft, and they're spaced some fractional dimension. And then on the other side, I did the same thing, as you may recall. Right. So that hole is the same equal space to that hole, and then it's spaced in the same plane, some fractional dimension from the feed shaft. So what I'm going to do is come off of here with like a side plate and come down, and then go across the bottom of the apron, and I'm either going to, just for the sake of speaking about it, put notches in it, or have some sliding stops that are in the form of like a little notchy thing that I could slide and lock down and adjust perfectly. So let's put my Loctite there. So that's the plan. So a side bracket, a plate of steel coming down, something going over it. I thought of using a piece of 1/2 inch fine thread all thread, or even 5/8 fine thread all thread going across it underneath. This worked out well. These brackets and the pieces of aluminum blocks for that support rod for the feed handle. But as I kind of explained, that rocker box torques. It pivots off the front, and then there's the bushings in the back. Bushing, and it's just supported in the front, but it wants to twist and bind the bushings. And then, even those are brand new bushings, and I think I got 0.02 of clearance between the bushings and the shaft, and it's, that's fairly tight for something like this that needs slop to move. It's still putting them gears in a bind. Now maybe, with that detent plunger, and it sets the up and down, the diameter of that gear, the diameter of the detent plunger controls how high that rocker box sits, which in turn controls how deeply the gear teeth mesh from the worm gear to the worm wheels. So, and I played with that, and I showed my last video, one of my last videos, about how I turned the diameter down and, got everything so they would mesh kind of equal on both the cross and the long feed. Maybe I'm just meshing the worm a little too tight, a little too deep in the worm wheels, and that movement of the rocker box is causing me some binding, but I don't think so. I think this is just, once this thing wears in and gets sloppy, I think it works better, but you shouldn't have to do that. You shouldn't have your worm gear floating, flexing off axis with, respect to the mating gears. So I'm gonna get up because my knees hurt. So that's what that is. The apron works really well as far as the engagement of the handles. But I think I need to put an additional support stop with notches for the different two positions across the bottom of the apron. And I know it sounds like, and yes, I am doing a lot of work, but I think I'm curing a mechanical deficiency, mechanical oversight, because you can see, you can measure with a dial indicator, a plunge indicator, at least 25 thousandths of fore and aft movement. All right, enough talk about that. Hey, I set my Oloris tool post up on the beautifully ground compound slide, top slide. This is a CA, and I need to make the T-nut and everything. I threw a boring bar holder on there, and I got it near the top of the dovetail. So what I was doing is seeing how much on center it is, and if I need to shim the tool post. And I don't know if you can see that. It's right on center. I'm looking down the spindle bore, which is 3 1/8 spindle bore. So that looks to be on center, but you know what? It's a little bit. It's kind of to the high side, and I got some space below. And where that sheet of paper is, I can always put a shim washer, spacer, whatever you want to call it. So it looks pretty beastly, looks pretty beefy, sitting up there. I can't wait to get my apron 100% sorted out. And oh, so another thing. There is a planed surface on the back of this lathe with bolt holes, and it goes the full way. I was scraping the paint off up to a certain point, and then bolt holes. I think this back piece, it's not for a taper attachment. The taper attachment goes up on the bed. I think this might have been like Keith Fenner's lathe that had a hydraulic tracer. I don't know if anybody can comment that has a lathe like this. I'd love to hear from you. I think that's what that's about. And I noticed on Keith Fenner's lathe, he's got the hydraulic tracer slide in the back, and I'm assuming it bolts on these holes here. This would be a great rear tool post for cutting off or whatever. Yeah. So, and I've seen in the manual, this top slide it goes the full length of the carriage, and I've seen in the manual shorter versions of this. And even there's a regular standard cross slide, and then there's a taper attachment cross slide, which this is. But even the taper attachment cross slide, I don't think is quite this long. This is a ton of bearing area, and which is great. But that just kind of maybe even lends more to the argument that this probably had a hydraulic tracer at one time. So I believe this had the hydraulic tracer like Keith Fenner's lathe, and I also believe it had the quick threading, had another set of half nuts on the front, and I talked about that in another video, I think, where those tapped holes are. I forget the name of the company. It was like a Harding lathe or a Hendy lathe that has, you can only start the threads at the right spot every time. You don't have to watch the thread dial. There's a rapid threading unit. That's what it was. So I believe this lathe had the rapid threading unit, and I believe it had at one time the hydraulic tracer. So I believe this was a Cadillac lathe at one time, and I believe that's why somebody actually rebuilt the apron with new put bushings in it where it never had bushings, and
So if this lathe could talk, but the reason I'm going through all this effort is because it's such a cool lathe. With a 3 1/8 spindle bore and with the gap, I think it'll swing 26 or 27-inch faceplate in the gap. It's the short lathe. This is the 54. I think they made a 54 and like an 82-inch or something. But this is a little bit shorter one, but that's okay. It's plenty long for me. And the reason a shorter lathe, a little bit shorter, is okay is because you can do work through the headstock. It's not like a typical 1.5 or 2-inch through the headstock. It's that big 3 1/8. So that's why I'm pretty jazzed about fixing this lathe up. And I don't mind re-engineering some of the little quirky things about it. And they are quirky things. That power feed, I believe, is truly kind of an engineering problem. And we'll talk more about that. I'll make a video exclusively talking about things that are brand new, like cars and durable goods that have engineering problems, tractors. Oh yeah, like my tractor with the broken dashboard from the vibration, you know, it's just cheap plastic. Just because it's made brand new in a factory does not mean that it has perfect engineering. There's so many flaws that are put out and sold to the American public. Well, any public, really. But anyways, so that's what I got. Kind of enjoying hanging out in the shop tonight with Pam Anderson and the girls. And come out here and plan my next move on the weekend. It's a Thursday night. Is it Thursday? Yeah, Thursday night. And sort of planning my next move on what to tackle when I have shop time here on Saturday and Sunday. So that's what I've been working on, and I think I have some more work to do based on the video footage I was just showing you guys. What do you think? These look pretty awesome up here. I didn't tighten them yet. But that's going to be, so these two there's passages that run down and they oil basically what that's oiling and what that's oiling, and this one oils what that oils. And what it oils is these the shaft bushings, you know, in the headstock. So kind of redundant, but I got felts in there. It'll provide more consistent, continuous lubrication. And I've still got to put my my wipers on the ways. Maybe I'll get that done soon. And then I got the tailstock. I got it off the hoist. I got it on the floor so it's not running into you. I think the tailstock's in okay shape. It's a Morse Taper 4, which has been spun a little bit. I do have a Morse Taper reamer. I hope it's not too hard to ream. That could be a project to set up in the Brown & Sharp 13. Oh, wait a minute. I didn't adapt the ID grinding spindle yet. Shoot. Well, there's another project. Tools fix tools. Machines fix machines here in Doozer shop. I'm going to end it here. It's been 45 minutes of me yakking on this. So I think I got a direction for the weekend. Playtime here in Doozer shop. Until next time, hope you enjoyed the video. And keep following my progress on the 17-inch Colchester lathe. And until next time, this is Doozer's shop.